Good morning, this is Kasturi De. Today I'm going to start with the sound chapter. It's a physics chapter according to ICSE syllabus class 7. Okay, so what is sound? It is a form of energy which is produced by a vibrating object or vibrations of a part of an object that produces sensation of hearing in our ears. Okay, so it's a form of energy which is produced by a vibrating object. When the object is vibrating or any part of the object is vibrating, that produces an energy which produces a sensation which reaches our ear to help us to hear. Okay, and form a sensation of hearing. Okay, so this type of energy is called sound. Like blowing a whistle, where the vibrations of the particles of air which produces the sound. Then while speaking, when we speak, our vocal cords vibrate, which produces a sound in the larynx. Larynx is a voice box which is present in our throat. So so that is the sound which is produced while speaking. Then striking a bell. When we strike a bell, the vibrations are produced in the metal, as well as which is passed on by the particles of air into our ears. Okay, this produces a sound. Then sources of sound. What are the sources of sound? Like a tuning fork. Okay, any musical instrument. Okay, then we human beings also produce sound. Then speaker, then mosquitoes and bees, these all produces sound. These are all the sources of sound. Okay, so first we come to tuning fork. Tuning fork is a U-shaped metallic piece with a stem in the middle. Okay, it looks like this, Y-shaped. It is U-shaped upper portion with a stem down in the middle. When the pongs, these two are the arms of the U shape, these two are called pongs. Okay, they are set into vibrations when they are struck on a rubber pad. They produce sound. Okay, now any musical instrument like wind instruments, stringed instrument, percussion instruments. Okay, then reed instruments, all those instruments produces sound. But first we come to wind instrument, which produces sound by vibrating an air column inside the hollow part of the instrument. Then for example, French horn or trumpet. Stringed instrument, they produce sound when their strings are set into vibrations by plucking, striking, or by drawing a bow over the strings. Okay, see, when we pluck the strings or strike the strings of a violin or a sitar, it's a stringed instrument, no? So when we pluck those stringed instruments, they produce vibrations which causes sound. Then percussion instruments, which produce sounds when their stretched membranes are set into vibrations, like dholak, tabla. When we beat the stretched membranes, we produce the vibration. This produces a vibration in the instrument, and that produces sound. Okay, then we come to some reed instruments like mouth organ or harmonium. This produces sound when air is blown over it. Okay, then human beings. I told you human beings have vocal cords in the voice box. Okay, in the larynx portion, the upper part of the larynx, there is a windpipe in the throat region which do have two vocal cords like this. Okay, when they are in relaxed position, these vocal cords, they have a gap between two vocal cords are there. So they will have a gap between them when they relax. Okay, so between them through which the air passes through. Okay, when we are making a sound, what happens? These two come closer. These two vocal cords come together. They are made up of ligaments. Okay, they are stretched across, thus like the strings of a instrument, of a musical instrument. Okay, so these two come closer, narrower it between the space, the gap between them narrows down, and what happens? They contract and they start vibrating while producing a sound so that we can talk and sing or sing. Okay. Then the speaker. The sound is produced when they come in of the speaker vibrates. Okay, the cone of the speaker vibrates. Okay, the cone of the speaker, when it vibrates, they produces a sound. Then mosquitoes and bees, they produce a buzzing sound when their wings flap rapidly. Okay, now sound travels in air as a longitudinal wave. Okay, so what happens? Sounds travel in the air in form of a wave. What is a wave? Wave is a disturbance which is produced in a medium that carries energy from one part of the medium to the other part of the medium without the transfer of matter. Matter does not get transferred, only the energy get transferred from one part to the other part of the medium. Okay, and this produces a wave. Okay. Now, the objects, when they vibrate, they transfer the energy to the molecules of the surroundings, the surrounding medium, and the molecules begin to vibrate and they form waves. Okay, waves are formed. Now, vibrations of the particles of the medium, they can be in the same direction or in the direction perpendicular to the direction of the propagation of wave. Okay. So, particles vibrate in two ways, that is in the same direction, that produces a longitudinal wave, and when the particles vibrate in the perpendicular direction, in the direction of the propagation of the wave, in which the wave is moving, wave is propagating, in that direction it can be, the vibrations the vibrations of the particles can happen, or it can happen in the perpendicular direction, that is in the 90-degree direction. So in the same direction, the graphical represented of the longitudinal will be like this. Longitudinal wave will be like this. Okay. And when the graphical representation of the transverse wave will be like this. Okay. So this will be in the longitudinal wave will be like this. This will be compressions. Compressions when the air will be, the particles will become closer, and then there will be alternate rarefaction. First there will be first there will be compression, then there will be rarefaction, again compression, rarefaction, like this. So in that way the longitudinal wave carries on as the sound travels in air. For example, when we clap our hands, the air particles between our hands get pushed, that is, they produce a compression. These particles hit the air particles outside our hands and push them outwards, and they form a rarefaction which further hit the neighboring particles, and they pass on the energy to them, and this way the wave is formed. This continues until the particles next to your eardrum get hit. This wave then reaches our ear is heard as a clap sound. This vibration travels as energy. Okay. Then sound requires a medium to travel. Okay, sound cannot travel in vacuum. Okay, so there is a material medium required for the sound to travel, like solid, liquid, or gas. Okay, then for example, if we take a calling bell inside a bell jar, we take a calling bell inside a bell jar, we connect it through a wire and battery. Okay, so inside the bell jar, we adjust the bell jar in such a way that we create a vacuum inside the bell jar. Okay, now what we do, we switch on the calling bell. We see that the hammer of the bell starts beating the drum, beating the bell, gong. So it should produce a sound, but we are not able to hear that sound because there is a vacuum created inside the bell jar. As soon as we pump certain amount of air inside the bell jar, we'll start seeing, we'll start hearing a little bit of sound. As we pump in more air, we'll see that more of sound is, it's becoming more, we can hear a more sound. Intensity of sound is heard more. Okay. So from this experiment, we can see that, or rather we can say in the other way around, that previously there was air. Now as soon as we are pumping out of the air, we see the sound is becoming feebler. Okay, the sound heard, which is becoming weaker and weaker, and after, when there is no air, we will not hear any sound, even if the switch is still on. Okay, so this proves that air should be needed, or rather a medium should be needed to propagate sound. Okay, sound to travel. Some terms which are related to a wave. Okay, first is one vibration or oscillation. One complete to and fro motion of a wave about its mean position is called one oscillation or one vibration. See, this way, and coming to this portion, it completes one oscillation or one vibration. Okay, so one rarefaction and one compression forms the next, one rarefaction, and next to that one compression forms a total wave or one vibration. Now wavelength, the length of wave corresponding to one vibration. I told you the length of one wave is called the wavelength. One vibration is called the wavelength. It is denoted by lambda and it is measured in meter. Then amplitude. Amplitude is the maximum displacement of the wave on either side of its mean position. It's also measured in meter. Okay, this is the maximum displacement of the wave from its mean position. This is the mean position, the line, and either side the wave, the highest maximum place, that is the wavelength, the amplitude of the wave. Due to friction, gradually it decreases, amplitude gradually decreases in air because due to friction, and ultimately it dies out. Okay. Now time period. Time period is the time taken by a wave to complete one vibration. To complete one vibration, one compression, one rarefaction, to complete one vibration, it forms, the time taken is known as the time period. It's denoted by capital T and it is measured in seconds. Next we come to frequency, the number of vibrations which is produced by a source of sound wave in 1 second. Number of vibrations which is produced in 1 second is known as frequency. It's denoted by small f, a small n, and the SI unit is hertz, Hz. Okay, so f is equal to 1 by t hertz, and it does not depend on the amplitude of the wave. Frequency, f is the frequency of the sound producing the wave, and speed of the sound v is equal to f into lambda. Okay. So I stop here. I'll continue with the next rest of the chapter in the next video. Please go through this. If you have any doubt, please write in the comment box. And if you like the video, press the like button. And if you have not subscribed yet, or you are a new viewer to my channel, please do subscribe to get the notification of my next video. And please get the notification, press the bell icon. Okay. Thank you.